This is a 6.5 practice. First problem you had, a local garden center says that a certain variety of tomato plants produces tomatoes with a mean of 250 grams and a standard deviation of 42 grams. You take a random sample of 20 tomatoes and calculate their mean weight. Okay, so 20 tomatoes take their weight. Now, if I was going to make a sampling distribution, take a whole lot of samples of size 20 and keep finding their mean. I know the mean of all those X bars would equal the mean of the whole population, which was 250 grams. And I know the standard deviation of all those X bars would equal the standard deviation of the population divided by the square root of n, how many there are. So 42 divided by the square root of 20 tomatoes is 9.39. Okay, so there's part A. Part B says to interpret the standard deviation. Well, let's start with this. In a sample of 20 tomatoes, the weight will typically, the mean weight of those 20 tomatoes will typically vary from the mean, so from 250 grams by about 9.39 grams. Okay. Number 2, that a cereal company's cereal box advertised that 9.65 ounces of cereal contained in the box. In fact, the actual amount was normally distributed with a mean of, I know my mean of my sampling is going to be 9.70, standard deviation. Okay, the standard deviation of the population is 0.03, but I'm going to take 5 boxes. So I'm going to divide it by the square root of 5 for my standard deviation. So 0.03 divided by the square root of 5 gives me 0.0134. Okay. What is the probability? Okay, so now I'm going to go to Desmos. And now my mean is 9.70 with a standard deviation of this, right? So if I add it and subtract it, okay. What is the probability of the mean amount of cereal in 5 is at most 9.65. Okay, so we have 9.65 something here, and at most 9.65 would be that area there. Okay, so we want to find the probability that the mean is going to be at most, so it's less than or equal to 9.65. So I'm going to go to Desmos and find this area right here.
Okay, so we know that the population was normal, so my sampling distribution is also going to be approximately normal. And we said the mean was 9.70, comma, standard deviation of 0.0134. And we want to know probability of less than 9.65, so max of 9.65. Okay, so 9.65 is not very probable at all. So 0.000095, so very, very small probability that will happen.
And the third one for you, it says estimating cholesterol. Suppose that the blood cholesterol level of men aged 20 to 34 follows a normal distribution with a mean of 188 and a standard deviation of 41. Okay, but that's 41 as the population. So my sampling distribution, when I take a sample of size 100, I have to divide by the square root of 100. So that square root of 100 is 10, that'd be 4.1. Okay, so I know it is normally distributed with a mean of 188, standard deviation of adding and subtracting 4.1. Okay, find the probability that I get a sample that's within 3 plus or minus 3. So minus 3 would be 185, and adding 3 would be 191. So I want to know what's the probability that's between those two numbers there. Okay, so I'm going to go to Desmos and find that.
Okay, so once again, we said the population is normal, so my sampling distribution is normal, not binomial. It is normal distribution. We said our mean was 188, and our standard deviation was 4.1. And we want to know the probability that those will be within 3, so from 185 to 191. Okay, so the probability there that it's between those two is 0.53536.
Okay, so we had the probability between 85 and 91 was 53.6% of the time it'll be within 3 points. Okay, a company used a machine to fill plastic bottles with cola. The contents of the bottle vary according to a normal distribution with a mean that is 298 and a standard deviation of 3. But if by sampling distribution we have size 3, standard deviation of 3 divided by the square root of n. Okay, so that would be 3 divided by 4, which would be 0.75. Okay, then we want to ask the question that it's within plus or minus 1 milliliter. Okay, so we have our mean at 298 plus or minus 1 would be with the probability between 297 and 299. Okay, so go to Desmos just like we did the other ones and find your answer. And just like you did in the other two, you found it in Desmos, and it's 0.818. Okay. An automaker has found that the lifetime of its batteries vary from car to car according to a normal distribution with a mean of 48 months and a standard deviation of 8.2 months. Okay, but if I'm doing it on 8 cars, my sampling distribution would be 8.2 divided by the square root of 8. And 8.2 divided by the square root of 8 gives me 2.90. Okay, so our question asks us to find A, calculate the mean and standard deviation. I have those. Okay, part B, interpret the standard deviation in a sample of 8 cars or batteries. The lifetime of the battery will typically vary from the mean of 48 months by 2.90 months. Okay, and then part C, find the probability that it's less than 42.2 months. Okay, so probability that the battery lasts less than 42.2 months. So once again, go to Desmos. We know it's 48 with a standard deviation of 2.90 from up here. 42.2 months. You want to find this area here. So go to Desmos and find it. And from Desmos, you get 0.023. Okay, so not a very high chance. So if they say it's going to last 48 months, if it only lasts 42 months, probably something wrong with it. Okay. Either you got a defect or their statement is not correct. Okay, so not part D, but number 6 for you. Refer to number 9. Suppose the average of these 8 cars turns out to be this 42.2. Based on is there evidence that the population really isn't 48? Yes. If it truly is a mean of 48 months, then there is only a 0.23% chance of 5 batteries lasting only 42.2 months. Okay, so either they are wrong or you got some bad batteries.